Okay, next one we're going to do is we're going to talk about LCM, least common multiple. Okay, least common multiple. Just going to go LCM here. Okay, so LCM, that's what we're going to call it. Least common multiple. That's where we have two or more numbers and we identify what is the smallest multiple that those numbers have in common. Okay. All right. This gets really important when we go into fractions and we go ahead and we talk about least common denominator and making the same denominator in order to add and subtract. So least common multiple. I'm going to start with 4 and 10. And I'm going to list them out. Right? That's how I'm going to do this because right now that's the only way we know how to get multiples. Okay? So 4, multiples of 4. 4, 8, 12, 16, 20, 24, 28, 32. Okay, I'm going to stop there. Okay. Now, maybe you already can tell by looking at this list of multiples what the least common multiple is, but if you can't, we're going to go ahead and list those out. 10, 20, 30, 40, 50, 60. Okay, I'm going to stop there. Okay, so now I go ahead and I look at those. I look at my list of multiples and I ask myself, okay, multiples of 4, 4, 8, 12, 16, 20, 24. I look at my list of 10, 10, 20. Oh, I see 20. Now 20 is a common multiple. Okay, 20 is a common multiple. All right, if I actually keep going and I go to 36 and 40, I can also say that, oh, 40 is a common multiple. Okay, now 40 is a common multiple, but it's not the least common multiple. It's not the smallest multiple that the two lists have in common. Okay, so 20 is my least common multiple. So the LCM is 20. Okay, I hope you guys can see that LCM 20. All right. Okay, now I'm going to have you go ahead and give you another moment to pause and find a least common multiple of two other numbers. Okay, so I'm going to erase this. Okay, go ahead and for me and find the LCM of 12 and 9. Okay, go ahead and hit pause, and then when you can figure out your least common multiple of 12 and 9, you can click play again, and you can check your answer. Did you press pause? Pause and do it. Make sure to pause. Pause. It's right. It's probably like right down here somewhere, right there. Right there on your screen. Pause. Yeah, pause. Okay, now you can do it. Okay, hopefully you hit pause and you went ahead and figured out your least common multiple of 12 and 9. Okay, so multiples of 12. Let's go ahead and list them out. Okay, multiples of 12. 12. 24. 36. 48. 60. 72. Okay. So hopefully you got that. Okay, now I'm going to go multiples of 9. 9. 18. 27. 36. 45. 54. Okay. Now I look at those lists and I ask myself, hey, is there a number in here that they have in common? Okay. And I go, yeah, there sure is. I see that 12 and 4 and 12 and 9 both have 36 in common. Okay. So, and in my list, that's actually the only one that they have in common. So right away, I know that, hey, that's my least common multiple. So the LCM is 36. Okay. Hopefully you got that one correct. Okay. There's another way we can find LCM. Okay. In one of the other videos when we talked about factoring and we talked about prime factorization and doing factor trees. So doing prime factorization is another way we can find the least common multiple of two numbers. It's not as easy as greatest common factor with prime factorization, but if you're working with two big numbers, it's probably the best way to go about figuring it out. Okay, so I'm going to do a factor tree of 12 and 18. Okay, so here's 12 and here's 18. Okay, I'm going to go ahead and do a factor tree for 12 first. I'm going to break it to 2 times 6, and then 2 times 3. Okay, so 2, 2, 3, right? So 2 times 2 times 3 is my prime factorization of 12. Now, prime factorization of 18. Okay, for 18, I'm going to go 2 times 9. And 2 is the prime number. I can stop there. 9 is not. I'm going to go 3 times 3. Both of those are prime. So my prime factorization is 2 times 3 times 3. Okay. So now I have that. Now, how do I use that to find my least common multiple? All right. So here's what you need to do. You need to look at the common prime factors that they have. Both of these have 2 and 3, okay, as their common prime factors. So I asked myself, okay, so if 2 is a common prime factor of these two numbers, which one has the most 2's? Okay, so looking, which one has the most 2's? 12, right? 12 has 2 2's. So I'm going to go ahead and I'm going to circle those 2 2's. Okay? I'm going to go ahead and circle those 2 2's. I'm going to put them right here. 2 times 2. Okay? I'm going to ignore this 2. Nothing to do with that 2 and the 18. This one had more, so I'm taking those 2's. Okay? Now I say, okay, 3 is another prime factor that they both have in common. Which one has more 3's? 18 has more 3's. Okay? This has 2 3's. This only has 1 3. So I'm going to go ahead and draw a box around these 3's. And I'm going to throw those 2 3's up here. Okay? All right? Now, if I go ahead and multiply this out, I will get the least common multiple of 12 and 18. 2 times 2 is 4. 3 times 3 is 9. 4 times 9 is 36. So 36 ends up being my least common multiple of 12 and 18. Okay, here's another moment to pause, and I'm going to give you 2 more to do. Let's find, using factor trees, let's find least common multiple of 16 and 14. Okay, go ahead, press pause, do your factor trees, get your prime factorization, multiply the most of each, and get your LCM. Thought I was going to do goofy stuff that time, but I'm not. So hopefully you pause and you went ahead and did it. Okay, so 16. We're going to break 16 to 2 times 8. And then I'm going to break 8 into 2 times 4. And I'm going to break 4 into 2 times 2. So I get a lot of 2's here. Okay, so something tells me that I'm going to end up doing 2's. So my prime factorization, 2 times 2 times 2 times 2. Okay, 14. 7 times 2. Both of those are prime. I'm done. Okay, so now I look. 7 and 2 are the common primes here. Which one has more 2's? Obviously this one, right? 2 times 2 times 2 times 2. Well, that right away I just know that's 16. Okay, all right. 2 times 2 times 2 times 2. I'm using all those. Okay, how do I know that it's 16? Well, once you get your prime factorization, you know that when you multiply them all together, you get that number. Okay, so 16, so 2 times 2 times 2 times 2. 7 is another common one. This only has 1 7. It's still okay. We're still going to use it, okay? Yeah, we're still going to use it, okay? So times 7. So now I have to do 16 times 7. Okay, so what is 16 times 7? Maybe I go ahead and do that on a little scratch page out here. 16 times 7, 6 times 7 is 42. 7, 8, 9, 10, 11. 112. LCM would be 112. Okay, so that's a really good example of why we might want to use factor trees, because if we do least common multiple and we list multiples all the way to 112, we might get confused and we might get lost up there or something like that. Okay, all right. Yeah, it's only probably the first 6 or 7, but with 14 and 16, it's hard to count by those. So maybe in this case, doing the factor trees was the best case scenario. Okay, one more thing we're going to do, and that's a word problem. Okay, and for the word problem, I'm actually going to take 2 magnets here. Okay, you have 2 gears here. Okay, and I'm going to call these gears actually model Ferris wheels. Okay, Ferris wheels. So this one spins, this one spins. Hopefully your Ferris wheels don't spin that fast and you go flying off into nowhere. Okay, but these Ferris wheels spin around. Now, the small Ferris wheel takes 24 seconds to go around. This small Ferris wheel, 24 seconds to go all the way around. So I'm going to label that 24 seconds. Okay. The large Ferris wheel takes 40 seconds. Okay. So if I'm riding in this car on the small Ferris wheel, and my friend is riding in this car on the big Ferris wheel, and they start to go around. So this one starts spinning, this one starts spinning. The question is, when will both of us be at the bottom of the Ferris wheel at the same exact moment again? Okay. Remember, this one takes 24 seconds to go around. So this is a little sped up. See, that was 24 seconds. But this one takes 40 seconds. Okay? So obviously, this one's going to go around a few more times than this one, right? Okay, so I'm going to go around a few more times than my friend is. Well, we need to find least common multiple, because what that's going to do is going to tell us when we're going to get to this exact point again. Okay, so at what point do we have a common multiple? So at what point do we have the common point where these two will meet at the bottom again? Okay, so least common multiple of 24. So LCM of 24 and 40. Okay. All right, now we can go ahead and list those out if we want, okay? But really, 24 and 40, I don't think I really want to list those out. Okay, let me see. Okay, so 24, when I have 24, plus 24 is 48. Okay. Plus 24 is going to be 60, 72. Okay. Let me just make sure. 48, 6, 7, say 72. Okay. And then another 24 is going to be 96. Okay. Another 24 is going to be 96 and 24. That's 10, 9, 10, 11, 12. Okay, will be 120. Okay. Then another 24 will be 144. Okay. Then another 24 would be 168. Okay. So now I have a list there. So this 40 would be 40. 80. Just count by fours and add a 0. 40, 80, 40, 80, 120, 160. Oh, 120. So listing them out here did actually work, and it wasn't too bad. So the LCM is 120 seconds. Okay, because each of these are in seconds. Right, so listing them out didn't go that badly. The only problem you might have had was, like, I had to do a few where I had to really make sure that I added the 24 and I counted by the 24 the right way. 40 was easy. Again, I just went ahead, counted by fours and added 0. Okay, so there you go. Okay, again, if you have any questions, you can go ahead and put them in the comments below. Go ahead and like the video. Go ahead and subscribe to my channel so that it comes up and you can get more videos of mine whenever I post them. All right? Have a good one.